Hello, this is Jang Jang. I will explain I2NSF, consumer-facing interface young data model for data modeling and remote control for networks and security course. This is Jang Jang. This figure shows I2NSF framework architecture. Today, we are focused on consumer-facing between I2NSF user and security controller in the I2NSF framework. You can refer to this document. You click this link to access I2NSF consumer-facing interface called the CFI Young Data Model. Basically, consumer-facing interface CFI is used to register user or device information into NSF database to translate the high-level young data model into low-level security policy based policy over NSFI, such as NSF-facing interface. So in framework of I2NSF, each vendor can register their network security functions called NSFs using developers management system DMS with the security controller. Then I2NSF user, such as an application for a security administrator, such as a web application using front end and back end for web, can configure the NSFs by defining high-level security policies. Most vendors provide various proprietary applications or tools to define security policies for their own NSFs. The consumer-facing interface called the CFI is required because the applications developed by each vendor need to have a standard interface specifying the data types used when the I2NSF user I2 administration website over dashboard and security controller, that is network operator management system, communicate with each other using this interface. Therefore, this document specifies the required young data model, such as their data types and encoding schemes, so that high-level security policies or configuration information for security policies can be transferred to the security controller through the interface called the CFI. Security controller will use the given information to translate the high-level security policies into the corresponding low-level security policies. High-level security policy will be delivered using CFI, and corresponding low-level security policies will be delivered via NFI. The security controller delivers the translate security policies to the NSFs according to their respective security capabilities for the required security enforcement. Okay, this class will see the information model and data model for consumer-facing interface called CFI. The high-level abstraction of CFI, you can see this is a CFI information model. This figure shows consumer-facing CFI is used to make policy. Policy consists of rules. Each rule consists of event, condition, action. Also, CFI is used to register endpoint groups such as user group, device group, location group, okay, URL groups into NSF database for translation between high-level young based policy and low-level young based security policies, and also threat feeds is specified. This is used to provide content-based security services. The CFI would be built using a set of objects, with each object capturing a unique set of information from an I2NSF user needed to express a security policy. An object may have a relationship with various other objects to express a set of requirements. The Yang data model in this document captures the managed objects and relationship among these objects. This model is structured in accordance with the event condition action. It is called the ECA policy model. So we have this information model. Endpoint groups consist of user group, device group, location group, URL group, and voice group. User group specify users like employee in company, corresponding to certain IP addresses. Device group also, such as IoT devices or web servers, something like that. They also correspond to some IP addresses. Location group is a geographical some location group. URL is a website URLs. And voice group is voice over IP or voice over cellular networks groups. So in Yang tree diagram for CFI, consumer-facing interface, one important thing is the endpoint group. So I explained those groups. The first group is a user group. So right-hand side, we have a user group, name, MAC address, and the IP, version 4 or version 6 IP address. Eventually, username translated into IP ranges or prefix, okay, or subnet, also IP version 6 or the same, or MAC address. So user group object represent the MAC addresses and the IP addresses version 4 or version 6 that are labeled as a group of users such as employees in a company. This figure, right-hand side, shows the Yang tree of the user group object. User group object shall have the following information: name, MAC address, IP version 4 addresses, IP version 6 addresses. Device group is defined network devices such as web servers or IoT devices. This figure shows a device group like user group, name, IP version 4 addresses, IP version 6 addresses, and application protocol like HTTP or HTTPS, voice over IP, something like that. Location group, this group is define a group of geographic locations such as country, region, and city. Okay, the right-hand side we have location group consisting of country, region, city. Also, it has some IP version 4 addresses, IP version 6 addresses. The country, this field represents the two-letter ISO country code, like JP, Korean case KR, Poland case PL, US case United States. Region represent the region code conforming to ISO 3166-2. Example include the ID RI for Riau province of Indonesia and the NG-RI for Rivers province in Nigeria. City. This field represents the city of region like Dublin, New York, and Sao Paulo. Location group. IP version 4, IP version 6 specify IP version 4 addresses as an IP version 4 prefix or IP version 6 address range for the location group. Version 6 also similar, you can define. And the endpoint group for CFI, the user group and the voice group, the URL group and the voice group. The URL group represent the collection of uniform resource locators such as URLs or host names labeled into a group, such as SNS website. SNS stands for social networking services. So we have this kind of young tree user group, URL group. The name is the name of this object. URL represent URL, and the voice group is represent the collection of SIP service. SIP is a voice over IP protocol session initiation protocol. So this young tree shows SIP, okay, name and SIP ID. The SIP ID represent the SIP identities in SIP URI, the scheme. Refer to section 19.1.1 of RFC 3261. From now on, I will explain young tree diagram for CFI threat prevention. So threat prevention model describes information obtained from threat feeds. So threat feeds describe the security attack threats, sources for obtaining the threat information. The presented information contains the features or attributes that identify a well-known threat, such as signatures or payload, some bitstring pattern, to prevent malicious activity entering the secured network. We have two kinds of object, threat feed, payload content. So threat prevention information model consists of threat feed and payload content. We'll see, okay, one step at a time. Threat feed represents the threat feed which provides the signatures of malicious activity. So this figure shows the threat feed list, name, ISC permit. So name is the name of this object. IOS represent the indicators of compromise. That is the critical information of patterns or characteristics in the threat feed that identifies malicious activities. The format for ISO, we have examples of sticks, MISP, MISP, Open ISO, and IODF that represent the threat feed. So also we have the format. This field represent the format or structure of the IOC field for the threat feed, such as sticks stands for structured threat information expression. This is OASIS standard expression. MISP core, you can refer this one. Open IOC and index incident object description expression format IODF. You can refer to RFC 8727. This can be extended depending on the implementation of the existing threat feed. So note that the information of threat feed, a failure of IOCM format, is used to information to alert or block traffic that matches IOCs identified in the threat feed. This information is used to update the NSFs having various content security control capability, such as using the content of payload matching with this thread feed, we can filtering out. So the capabilities IPS, intrusion prevention, okay, service, URL filtering, web filtering, antivirus, and voice over IP and voice over serial network, like LTE and 5G filter, derived in this I2NSF capability data model. Now, let's take a look at payload content. Okay, so this object represent a list of low binary patterns of packet payload content. They are after a transport layer header like TCP to describe a thread. This figure shows the payload content consisting of name, description, content. Okay, content also consists of content, depth, starting point. Starting point, we have two kinds, offset and distance. Okay. So our name is the field identifies the name of this object. It is recommended to use short and simple words that describe the content. For example, the name backdoor indicates the payload content is related to a backdoor attack. And the description, this field is used to represent the description to further describe the content field in detail. This is a relevant description for humans. This field is not mandatory, but it is recommended to use the field as it is useful for future usage. And the content is used to represent the payload content patterns, such as data after a transport layer header, which means the payload, which are involved in a security attack in binary. If multiple instances of content are defined, which means we have more than one content for payload security check, all defined contents must be matched somewhere in the session string. So we can specify the separation using offset and distance. Offset is the new pattern started from this offset. Okay, this is an absolute location. Distance is a relative. The first security some threat information specified after that the next one. So after the end of the previous security content, distance specified the relative position of new security content. So we explain next. Okay, so the contents represent the payload contents, right? So I explain, and so content patterns should be matched based on the order given by the user. Scope of a payload to be matched can be defined by depth and offset or distance field. We can see the offset and distance is a member of a starting point. Okay, so the field specifies the starting point of matching the content pattern to the payload. So this field is undefined case. The content pattern should be searched from the beginning of the payload. The starting point can be defined either offset value or distant value. The offset keyword specifies where to start the searching for the specified content pattern. Okay, here, first one, offset is calculated from the beginning of the payload after the transport layer header, and distance keyword specifies how far a payload should be ignored before starting to search for the next specified pattern relative to the end of previous specified content pattern match. So we can comparison between offset and distance. This can be thought of as exactly the same as offset, except it is relative to the end. So which means the distance case relative to the end of the last pattern match instead of the beginning of the packet. You guys need to note this field cannot be used, okay, if the content is first order, okay, because this is a relative location for the case of the distance. From now on, I will explain policy object. Policy object has name, language, priority usage, resolution, strategy, rules. So name is the policy name, language is description of young data model language like the US English. And priority case, we can specify priority type. We have two, priority by order and priority by number. Priority order case, the location of rules execute. Okay, this is according to the input order by user. And the priority by number is the actual priority value. So higher value means higher priority. Okay, so now resolution strategy explain how to resolve conflict that occur between actions of the same policy rule or different policy rules, okay, that are matched. So in that case, event condition pair has multiple action cases. Somehow we need to select one of the actions. So resolution rules is used. The default resolution rule is FMR, stands for first matching rule. So we have 1, 2, 3, 4 multiple actions. The first matched action should be executed. The rules is the list of rules to execute according to event and condition. Those rules are defined for implementing business requirements such as the first, supporting communication between two endpoint groups. Remember, endpoint groups are user group, device group, URL group, voice group, something like that. And preventing, secondly, preventing communication with external or internal identified threats. Thirdly, controlling access to internal or external resources for meeting regulatory compliance. An organization may restrict the certain communication between a set of users and applications. For example, the threats may be identified from threat feeds obtained from external external sources we saw previously, like IOC. Note that rule conflict analysis should be performed by a monitoring service for policy rule conflicts in security controller to detect such rule conflicts among the policy rules installed into NSFs. Okay, so the policy object we saw, right? So each policy has the actions, including, right? And the policy has rules. Rule star means the multiple rules. So means a list of rules to execute that define event and condition. Okay. So according to ECA policy model, we execute a corresponding action. So this yang tree of rules consists of name, priority, event, condition, action. Name is rule name, and priority is used to execute the rule. in order to specified by the priority. So if the field can be given when the policy's priority usage is priority by number. This is priority number, right? Order is just the physical order of the rule. Event is specify the event of rule. Condition specify the condition. Once certify the event, condition is checked to whether to execute the action or not. If there is no action, explicitly implicit action is to drop traffic. So the event. So event here we can see event has two types: system event and system alarm. So this is Yang data modules container event. So the description of event, this it has two, okay? System event, a list of leap list, and the system alarmers leap list, okay? So the each system event, this type is from I2NSF monitoring interface system event, okay, identity, and the system alarm is referred to the time I2NSF monitoring interface system alarm. So the event object is describe the event information. So okay, each object has the following information. System event is a warning like any changes of configuration, any access violation, and the information of sessions and traffic flows. And system alarm is a warning related service degradation in the system hardware, such as the CPU or memory is overload or malfunction. So now we will see the rules condition. So rule has event condition action. So a condition case, firewall condition, DDoS attack, DDoS condition, or antivirus, and payload virus payload for content security, and the URL category, voice, context, threat fees. Okay, those are condition. So specify the condition to execute corresponding action. So these fields are used to express the required conditions to trigger rule. NSF expects to be able to observe or execute. Okay, we have I think that there is some okay here. So here trigger rule, here we omitted the one words with, okay, with the corresponding, okay, let me explain something like that. So rule, okay, the rule with the NSFs expect to be able to observe or compute the values of those fields. Okay. This figure shows the part of a Yang tree for condition object. So firewall case, this field is used to filtering using layer 2 header like Ethernet MAC addresses or Wi-Fi MAC addresses, layer 3 network layer header, such as IP version 4 or IP version 6 addresses, and ICMP version 4 or ICMP version 4 or ICMP version 6, Internet Control Message Protocol version 4 or version 6 parameters, and transport layer protocol. This one is embedded L3 header, and the layer for transport layer header, like port numbers used for network traffic, okay, firewalling, and DDoS, distributed denial of service attack mitigation can be done using this field. The threshold limit for the rate of the network traffic to mitigate a DDoS attack. This threshold configuration can be given in terms of packet rate, byte rate, and flow rate. Antivirus is used to represent the configuration for an antivirus service. A specific security profile can be added to a security controller in order to update the configuration of the antivirus. Also, either a file name or path for such a profile can be configured for antivirus services. So maybe there is this one, some typo here. So file name path of such profile, just of, can be configured. And the payload, this field is used to represent the payload information of network traffic. So for payload content security with threat prevention object. And the URL category is used to represent the URL category to be filtered. We can use a group of URLs, okay, refer to section 4.4, such as SNS website. SNS stands for social networking services. And the voice is to use to voice over IP or cellular network services. This field contains the call source ID, call destination ID, and the user agent. This information describes the caller identification or receiver identification in order to prevent any exploits and attack, voice phishing. For example, some hacker can use your on SFE IT to charge a lot of money. So in that case, this service can prevent that kind of voice phishing, okay, malicious activity. Now we take a look at context. So context represents the extra information for condition, such as time, application, and device type, user condition, geographic location. So time is the time when to execute the I2NSF policy rule. We have two time, absolute time, periodic time. Absolute time means the exact time to execute this policy from starting time and end time. On the other hand, the periodic time represents repeated time with the day, week, month, or year information. Application is the packet matched with an application protocol like HTTP, HTTPS, FTP, etc. Device type is device type matched with the destination devices such as personal computer, Internet of Things device, network infrastructure devices. User condition means the users matched with the network by matching each user ID to an IP address. Geographic location is the geographical location matched with the location of a source or destination of a packet. Okay, lastly, thread feed contains the information obtained from thread feeds. This field is used to when security rule condition is based on the existing thread reports gathered from other sources. This is related to IOCC. Now, the last field of event condition action of rule is action. So action is actions that security administrator wants to perform based on certain traffic class. Two actions. The primary action is a mandatory action, event, and condition clauses are satisfied or met. So primary action identify the action when a rule is matched by an NSF or multiple NSF. So here action includes pass, drop, reject, late limit, meter, invocate the signaling, tunnel encapsulation, forward, and transform. So note that if the action is a late limit, the limit value should be given to the security controller in order to determine the threshold of the traffic rate. So we will see the example of DDoS attack mitigation service in this class later. Secondary action is used to identify the action when a rule is matched by an NSF, such as rule log and the session log. So this is the action yang tree. So let's take a look examples of I2NSF consumer-facing interface. Okay, the first example is restoration of endpoint group. Such as this yang tree shows the restoration. This is XML document is used to register endpoint information. So the endpoint information includes user group, device group, URL group, voice group. Okay. Basically, we want to register employees. This keyword match with this IP address is okay. The range. So employees indicate this range from this 192.0.2.11 through 192.0.2.90. These addresses are employees' IP addresses. Their laptop or the smartphone or their personal computers are using these IP addresses. Web servers also, these IP addresses are used for web servers. And also they are using this HTTP and the HTTPS, two protocols application level provided. And the URL group case, social networking services sites, these two URLs are for this SNS website keyword. And the voice group case, malicious ID case, we have two ID, SIP Alice, SIP Bob. Okay, so those are registered into NSF database for security translation, high-level security policy into low-level security policy. And secondly, this is the first example block SNS access during office hours using time-based firewall policy. Okay, so basically, this policy, I2NSF shapefile policy, has this policy name, and the rules is block access, SNS access during office hours. So you can see the source of SNS access is employees. This employees will be translated into this IP addresses range, and the target is SNS website. The SNS website, this is handled by later on your filter, okay, NSF, okay. Firstly, so this policy actually provided by a viewer and your filter, and this is some start end time. This is 9 o'clock in the morning, 6 o'clock in the evening, okay. This is the range, okay, and the period, okay. This 9 o'clock, 9, okay, Monday, Tuesday, Wednesday, Thursday, Friday, weekdays, okay. This policy should be enforced and weekly, and the action is a drop, which means during this weekday, this range of work time, employees cannot access URL website, okay, corresponding to SNS website. So mitigate, attack. So this is a security policy for DDoS attacks, okay. So we can specify threshold 1000 packets per second. This is policy name, rules name, okay. And this is policy name, and the destination is the web service, okay. So some hackers bot, okay, attack web servers. Their traffic is packets 1000 per second case they are dropped, okay, and then we prevent the DDoS attack. And the last example is okay, here, okay, we already explained, right? So this slide explains I just explained, right? So the web servers protected, right, over this rate, 10,000, 1,000 rate of a packet per second, the traffic is dropped, okay, to protect web servers. So conclusion. Today we studied I2NSF consumer-facing interface CFI young data model along with the information model, specifies the data models for the high-level security policy. The young data model uses ECA. So this is omitted one. So ECA policy rule, a policy model to activate rule. The data model provides an endpoint group registration for the translation from high-level security policy to corresponding low-level security policy using NSF database. So we will see the detailed translation in security policy translation section. Okay. So later on we learn security policy translator. Okay, so we'll see how to translate from high-level security policy to low-level security policy. In this class, the usage of I2NSF consumer-facing interface young data model is shown with XML examples like firewall and web filter, DDoS attack mitigator. So if you have a question, please let me know. Thank you for your attention. Bye.